And we will like to give meaning that as x goes to a, or maybe if x goes to a, then f of x goes to L. So we like to give meaning to basically the solution. Okay? And how can I give it? What do you think? What should be the? What should be the way? First we had some notion of how about if we say that for every, just think about it, for any sequence which converges to A, it's like, imagine I have a sequence xn, for every xn such that which converges to A implies, we think that what should be the images of that sequence should converge to what? L as m goes to. Something very natural. You get it? Okay? So we can discuss it later. Let's concentrate here. So means for any xn such that xn goes to A implies that f of xn converges to L. Now what is the meaning of convergence in, if we like to write it more rigorously, what is the meaning of convergence in meeting spaces? What is the meaning of xn? For epsilon positive, there exists a capital N such that the distance between xn and A is less than epsilon for all n bigger than or equal. And that's what the meaning of convergence is. So when I am writing this, that xn is converges in A, then obviously this convergence is going to be in X basically. Okay? While this convergence is going to be in Y. Okay? So that could be one of the big basically. And this N is very important actually. Now this sequence, so it's like, you know, this picture is misleading because we are kind of approaching it from left actually. But this xn could be anything. Left, right, whatever. Okay. And an additional assumption that xn is a kind of thing which is not equal to. It's not necessary that xn should be equal to. Okay? So it's like it should be something other than if we have xn equal to A, it's going to mean something else which we are going to later discuss it. Okay. Now just think about it. Using this definition, so that's what the rigorous definition of. So it's like we define new thing in the terms of something that we understand already. So just think about it. I have this, say limit x approaches to 1 and say x plus 5 is 7. Greatly. Obviously, this limit is true limit. But how can I to show that this is not a true limit in the sense of this definition. In other words, what is going to be the negation of this definition? What will be the negation of this definition? What will be the negation? But for any negation, what's negation for any? There exists. In other words, if you can give me a sequence, if there exists a sequence for which we have this, but we don't have this, you know, then it doesn't have this. Not equal to this. So give me a sequence which converges to 1. 1 plus easiest candidate. Okay. This goes to 1 and goes to infinity for me to tell you. Now, what would be f of xn? It is going to be 1 plus 1 over n plus 5. And this converges to what? 6, which is not equal to 7, and goes to infinity, and hence this doesn't make sense. The negation of this should be kept. Say that in a meeting space that goes to A of x is not going towards L, that means that we need to find a sequence for which this goes to A. L. Agree? How about showing that? How about showing that the limit exists? So I'll get more sophisticated in the moment. I'm just giving you kind of something very new. For example, I have the same thing at well, not 7 but 6. Okay. How are you going to prove that? So imagine xn converges to 1, okay, as n goes to infinity. So what is f of x? Xn plus 5, and is going to converge to, if you apply the algebra of limits, it's like if I apply limit here and limit here, and this guy, because it is given that it is 1, this is going to go to 1 plus 5, which is 6. Easy. And by same argumentation, you can actually show exercise in small that if I have a polynomial an x raised to n, where k x raised to k, where k runs from 0 to n, okay, so the finite degree polynomial. So this limit exists. This limit exists as x goes to any k. Okay. Not limit n goes to infinity, but limit x goes to pf. This should exist. Does it exist? Now, if it exists, it should be what? Let's move ahead. So I would like to define something more interesting. And I would like to define now what is meaning of f of a plus. You know this notation? What does it mean? Meaning that limit x approaches to a plus f of x. Give me definition for this. What should be the definition for this?
The main concept is a monotonic speed.
Where is monotonicity?
No, if you are approaching from the left side, xn should be increasing.
Why should we increase? It's a good candidate. For any, so you're going to say that this is true if and only if for any xn such that xn is bigger than a and xn is different from a and xn converges to a as n goes to infinity implies f of xn is 1. Agreed? This should be the definition. This is a sensible definition. It's like you are converging from, so it's like you are approaching from right at. Hence, the value of the function of going to approach from right to the point. And keeping in view that, I'm using this simple notation, but this simple notation is in metric spaces actually. I'm not writing it in the terms of metric actually. Assume that these definitions are agreed. And similarly, you can define f of a minus actually. Okay. And okay. So I would like to prove a result. Okay, something you might have learned on day one, first few weeks when we are doing the calculus on course. So what is the fundamental result in existence of limit?
That's a bit. That's the definition.
Have I talked about continuity? Are you seeing any word of continuity here? When does the limit exist? Exactly. So left limit and right limit exist and both are equal. Then you say that the limit exists. Okay? So I get to say theorem that if f of a plus and f of a minus exist, in other words, we can determine their values and their values turn out to be equal, then what? Limit x and their values, if for example turn out to be equal to L, then the limit x approaches to a f of x is going to be L. We know definition of this, so that's our assumption, and that's what we like to try to do. Hope that we know the definition of everything. Let's move ahead. Okay. Help me. What should I do?
Directly.
So how should I begin? So I would like to show this actually. So I would like to show this. What is the definition? Definition says that take a sequence which converges to A and then try to prove that the f of x basically f of xn is converges to basically f. That's what is the origin of
Since both way proof,
Huh?
it's both way theorem,
What do you mean by that?
double implication.
If this is true, then we should have this. But I guess that.
उसमें सर फॉर एनी होगा तो ये हम डाल सकते हैं उसमें जब हम बैकवर्ड जाएंगे then we will have for any xn xn goes to a this thing happens so that xn is general in these things f positive and f negative.
Like we can split that xn
In
into
cases,
two parts.
yes.
Anyway, so we'll get into that. So let xn be a sequence, okay? And I'm always assuming that f is a map from x to y, where x is a metric space and y is a metric space. Okay? So let xn be a sequence in x such that xn is different from a and xn converges to a, okay, as n goes to infinity. Okay? And my claim is that with this information and this information, okay, both together imply xn converges to L as n goes to infinity to y. Okay? Now this sequence could be an interesting sequence. Just think about this sequence. Imagine I have point A. Where could be xn?
Anyway, yeah.
Could be anywhere. Then what could be the possible situations?
Left,
Is it left or right?
no, it is greater.
Or it could be both. So it can be on left and right both actually. So you can have a term like, for example, you have, if you have maybe this sequence is an alternating sequence. This point is an origin point. Okay? Then you know it can just go beyond, it's like a jump around both sides. Okay, now so it's not necessarily that it should be on one side only. So you can have lots of interesting things. So it could be on both sides. It is possible that it has finite terms on this side and infinite terms on this side. Then you can have other way around. And it could be possible that it has infinite terms on this side.
Which side?
And it is possible that there is no term on this side and all terms are only sitting on this side. So there can be a whole lot of possibilities. Okay. So let's consider some of special cases. Let me define J minus. Okay, a set J minus. So this J minus consists of those indices of this sequence. So it consists of those indices addresses addresses those sequence for which xn is less than 0. Okay? So it's a collection. It's not a collection of terms, but it's a collection of term number actually. Okay, those n's for which xn is smaller than a, and naturally I could define n such that xn is bigger than a. There is no possibility of equality. Okay? Agreed?
Yeah.
Now, when I am saying that imagine all of the terms of sequence are on this side actually, what does it mean in the terms of these two sets? J positive what? Yeah. Let me hear it. Listen to me again. So I'm saying that all terms of this sequence are sitting on this side. What does this imply for these both sets?
J minus is null set and
J minus is null set actually. Okay? Because there is no term for which xn is smaller than a. Okay? But it means that J plus is everything. But what if there are finite number of terms basically on this side and infinite number of terms on the other side? This means that J minus is finite set, J plus is infinite. And you can have the situation where both are infinite sets. It makes sense. So suppose the first condition. Suppose the first case that when J minus is empty or finite. J minus is empty or J minus is finite. That's a way to say that something is finite. Is it making sense? So I can argue similarly for J plus as well. I can say that the next case could be that J plus is finite. So I'm going to prove this claim for this case and the same claim for other case, that when J plus is empty or finite, and then I'm going to prove this equation, that this convergence for the case when both are infinite. Okay? So this is the case, in all cases, no matter what your sequence is and how does it behave, like you're going to have this convergence. If you have this convergence, you are happy man. And women as well. Okay? We have that information. We're going to use it.
And this is existing.
This is the condition. So we have three things to this. So convergence of this, existence of left and right hand limits and their equality. Like this. See that it's easy to use the result, but it's interesting. Difficult to prove results. Not difficult, but it's fun. Okay, so if J minus is empty, we are done. Why we are done? I don't need to do anything.
the definition followed by it.
Okay? So if J minus is empty, then I know that limit n goes to infinity, f of xn is going to be equal to. So all of these xn's are bigger than a, okay, and they are converging to. So f of xn is going to converge to what? L r f of a plus n, which is equal to L. Okay? Just think about it. Because if you have, so f of a plus is L, it means that you take any sequence in which the terms are bigger than a, and that converges to a, f of xn always converges to L. So that's what the definition of this is. So we have a sequence, if J minus is empty, we have a sequence which converges to A and bigger than A, so by definition, you have the limit. Next case is that imagine J minus is an empty set. Well, not empty, but it's a finite set. So if it is a finite set, how does it going to look like? It's going to contain some terms.
N1, N2, N3.
What are going to be the terms? Okay. And why we have something similar in this case? Imagine so if this is a J minus and it's a finite set, so the least of a bound property tells us that it must have a supremum or it must have an upper bound. Not upper bound, but there must be a maximum element in this set. Okay. So imagine that K is maximum of J minus. Okay? K is maximum of J minus. Yes, J minus पे index is it. You have index.
सर क्या हम समझा सकते हैं J माइनस फाइनाइट है, तो मतलब जो xn है उसके कुछ फाइनाइट मेंबर्स हैं वो J माइनस में, बाकी सारे वो जो है वो Jn xn ग्रेटर देन a, तो क्या हम वो सबसीक्वेंस ले लें उसकी, वो सारे टर्म्स वो सबसीक्वेंस ले लें एंड देन हेंस वी हैव फाउंड अ सीक्वेंस.
That's precisely what we like. That's precisely what we like. Okay. So if this is the case, so imagine K is set to me, so it's like in this set K is the biggest number. In other words, after K, all of the terms are here actually. Okay. And they are converging to A. In other words, xn, where n goes from where to where? Say K plus 1. Okay, the infinity is on right of A, okay, and such that, so if whole of sequence xn is converging to A, then this subsequence is also going to converge. Xn converges to A. So if this is the case, we are done actually. We can again write the same thing. Xn approaches to infinity, f of xn is going to be f of a plus, and we have done that. Agreed? So we have to precise this thing.
Sir, we are doing this in metric spaces. So can we say these terms like right and left?
Can we say that these terms? Okay. So imagine x to be r. Okay.
Maximum or not the average set of the general.
We can generalize it, but in order to make sense, we can assume that we are talking about some kind of relation. Agree? So how many of people understood this statement? So we said that up to time k, okay, you know, this sequence can be here, I don't know. But after k, I know that all of terms are in right actually. So we got a sequence which is on the right of A, and since the right hand limit exists, so every sequence which converges to A from right, for that sequence f of xn is going to converge to L as n goes to infinity. That's what the definition of right hand limit is. Because that's a subsequence. Isn't that a subsequence? You know, okay. You know, we can say that if a sequence is convergent to some number, forget about the finite terms. You know, just see the tails of the sequence. Okay? So whatever is happening before k, it doesn't matter. is going to still converge to A atom. Doesn't matter. Alright, so that was the first case. So we can argue precisely similarly when J plus is infinite and J minus is. J plus is empty or finite.
And loss of the
Let's move to the other interesting case, the only interesting